Okay, so thank you for your attention. My name is Xiao, and I'm a PhD student in operations research at Columbia University. So today I'm going to present our recent work, Price Discrimination with Fairness Constraints. And this is a joint work with Maxime from McGill University and my advisor, Adam. So the background of this work is that discriminatory pricing has become common practices thanks to the development of e-commerce. On the other hand, the U.S. Civil Rights Act makes it illegal to discriminate against protected features such as races, genders, and marital status. However, the price discrimination practices has been shown to not comply. For example, there is a famous phenomenon called pink tax, which means that female customers are receiving higher prices in several services and products, such as haircut. Also, there has been systematic research showing that African Americans are receiving higher prices for Uber services, as well as higher loan interest rate. So fairness has become a serious issue in discriminatory pricing. However, there are no clear guidance on how to ensure a fair pricing strategy, which is exactly the focus of this paper. So in this work, we would like to answer two questions. First, how do we model fairness in the context of pricing? For this part, we propose a novel framework, and it is very different from the fairness in machine learning. And second, what is the impact of adding fairness constraints to the social welfare? The answer for this part is far away from a one-sentence answer, and we will discuss through this talk. So let me describe our model. We assume that there is a monopolist who is selling one product to two groups, group 0 and group 1. And for each product, the unit cost is simply C. Okay. For group I, we assume that the population size is DI, and we will charge price PI to this group. For the customer side, we assume their valuation is a random variable VI, and VI follows a common knowledge distribution FI. So given the price PI, the market share will be F bar IPI. Okay. We will use the quasi-linear utility here. So the surplus of a customer is simply the positive part of VI minus PI. And given this setting, the profit from group I is simply the population size D times the unit profit P minus C times the market share F bar IPI. And finally, we will use PI star to denote the optimal price of group I without any fairness constraints. So in this work, we considered four types of fairness constraints, which are fairness in price, demand, surplus, and no purchase valuations. Let's go through it one by one. So price fairness requires that the two groups to receive equal or similar prices. I think price fairness is actually the most straightforward one in the context of price discrimination, because price is the direct treatment, and we would like the two groups to receive equal treatment, right? This is price fairness. But for demand fairness, we require the market share of the two groups to be equal or similar. So one motivating example for demand fairness is the fellowship in college and universities. So in many cases, we offer fellowships to those students who are from low-income family or low-income countries because we want to ensure that different groups have equal opportunity to get the good education, right? So this is demand fairness. Surplus fairness requires that the average surplus of the two groups has to be equal or similar. So surplus is a very common metric in economics that measures people's happiness, and we would like the two groups to be equally happy. Okay, and finally, no purchase valuation is something new. It's basically the average valuation for those who cannot afford the product within group I. So it's not hard to imagine that those who cannot afford the product are also the victims of price discrimination, so we would like to take them into account. On the other hand, their surplus is always zero, so we would like to use their valuation to be the matrix, which is always positive and measures how unhappy they are when they cannot get the product. So no purchase valuation fairness basically requires that the two groups to be equally unhappy in a sense. Okay. So in our model, the fairness level is measured by a single variable alpha. Let's use price fairness as an example here. When alpha equals 0, it means no fairness. So in that case, the price difference will be simply the initial price gap, and we will use pi star to be the optimal price. On the other hand, when alpha equals to 1, it means perfect fairness. And in that case, we require the two groups to receive the equal prices. Okay. And for alpha between 0 and 1, we use a linear interpolation. So basically, we require the price gap, in this case, has to be less than or equal to 1 minus alpha times the initial price gap. So this is what happens to price fairness, but for other fairness measures, we impose similar constraints. So with this simple framework, our first question is, can we achieve perfect fairness simultaneously in multiple criteria? The answer is actually negative. We find that if the mean valuation of the two groups are not equal, then it is impossible to achieve perfect fairness in price, demand, surplus, and no purchase valuation all simultaneously. On the other hand, this result is actually not very complete, in the sense that mean valuation is just a necessary condition to achieve perfect fairness in multiple criteria, but it is very insufficient. For example, let's say the group 0 has an exponential valuation with mean 1, and group 1 has uniform valuation between 0 and 2. Then one can verify that only perfect fairness in price and demand can be achieved simultaneously, and any other pairs of fairness constraints cannot achieve simultaneously. So in summary, it is very hard to achieve fairness in multiple criteria. And due to this hardness, we will consider them separately and up to a certain level alpha in the rest of this talk. So specifically, we will use R of alpha to denote the total profit with alpha level of fairness, S of alpha to be the total surplus, and W of alpha, which is the sum of profit and surplus, to be the total social welfare. Under fairness constraints, the seller's objective is always to maximize their profit. On the other hand, the regulator's concern is the social welfare, and the impact of fairness constraints on the social welfare is not explicit. So toward this goal, our first step is to know what happens when we impose a little fairness, that is, when alpha is very small. We know that the profit must drop, but what happens to the surplus and social welfare? So for this part, we find that if both groups follow linear or exponential demand, which are very common in the literature, then under price and no purchase valuation fairness, the social welfare increases with alpha at first. Under demand and surplus fairness, the social welfare decreases with alpha at first. So this characterizes what happens when alpha is small, but it basically tells you the theme for the rest of this talk. So next, we will give a full characterization when the demands are linear. So for linear demand, the problem is simple and tractable. However, we would like to point out that the problem is generally non-convex and the solution is non-linear, even under the linear demand model. For example, this is how the price changes with respect to alpha under the 4 fairness constraints. And as you can see, for price, surplus, and no purchase valuation fairness, the price changes are non-linear, and the welfare changes will be complicated. Okay, so let's go through it one by one. First, price fairness. So for price fairness, we find that there exists a threshold value such that for alpha that is smaller than this threshold value, the profit is monotonically decreasing with alpha, the surplus is increasing, and the total welfare will be increasing with alpha. However, once alpha reaches this threshold point, suddenly all the 3 metrics, profit, surplus, and social welfare, will drop below the unconstrained cases. So the intuition here is that after the threshold point, the low valuation group is given up, and it will lead to a lose-lose situation between the seller and the customers. So if we look at a concrete example here, in this instance, the threshold value is close to 0.4, and as you can see, before alpha reaches 0.4, the price difference is smaller and smaller. However, after this point, the seller may find it unprofitable to even scatter the low valuation group. So in that case, he will simply set the price to be the optimal unconstrained price for the high valuation group. And in that case, the demand for low valuation group will be 0. And correspondingly, you can see that the social welfare is increasing in the first phase, and then suddenly it drops below the unconstrained cases. So the takeaway from price fairness is that a little fairness increases the social welfare, but too much price fairness may be restrictive and lead to a lose-lose situation between the seller and the customer. For demand fairness, the story is simple. As alpha increases, we find that both the profit and the surplus is decreasing with alpha, and correspondingly, the welfare must be decreasing. So for demand fairness, it always leads to a lose-lose situation between the seller and the customers. For surplus fairness, the solution under the surplus fairness is actually very complicated. It's actually a root of quartic function. However, we are able to characterize what happens to the social welfare. We find that for any positive alpha, the social welfare is lower than the unconstrained cases. So surplus fairness always leads to a worse situation in terms of social welfare. So if we look at the example we have, you can see that the price change is nonlinear, and you can see that the profit is monotonically decreasing. The surplus is actually first decreasing, then increasing. However, the total welfare is always lower than the unconstrained cases. And finally, we look at no purchase valuation fairness. For this case, there is again a threshold point. So before this threshold point, the trend is exactly the same as price fairness. Basically, the surplus is increasing and the social welfare is also increasing. What is different is that even alpha reaches this threshold point, although the closed form solution is different, we can see that the surplus and social welfare are still monotonically increasing. So together, this means that the social welfare always increases with alpha under no purchase valuation fairness. So you can imagine that under linear demand model, no purchase valuation is simply half of the price. But the difference between no purchase valuation fairness and price fairness comes from the fact that under price fairness, it is possible for the seller to set a super high price to the low valuation group such that the demand from low valuation group is 0. But for now, you cannot do that because even you set a super high price for the low valuation group, it cannot improve the no purchase valuation anymore. So in that sense, you have to lower down the price for high valuation group, and it will always increase the social welfare. So under no purchase valuation fairness, the social welfare always increases with alpha. So this is what we have for the baseline model. In the paper, we also consider what happens when we have multiple groups, and each group follows a different linear demand. And for this part, we show that under demand, surplus, and no purchase valuation fairness, all the result extends. Namely, for demand and surplus fairness, the social welfare is lower than the unconstrained cases. And for no purchase valuation fairness, the social welfare is increasing with alpha. For price fairness, the things are quite different. The group exclusion may still happen under restrict fairness constraints. However, the situation is more complicated. So here I'm showing you what happens when there are 3 groups. So you can see that the left panel is the price changes. There are actually 4 pieces of linear functions for the price changes. Correspondingly, if you look at the social welfare, which is the blue curve here, you can see that it is first increasing, then drop, and then increasing and drop. So each drop indicates a group exclusion. And you can see that after the group exclusion, the social welfare could be either higher or lower compared to the unconstrained cases. And finally, we test our findings numerically in some other common demand models like exponential, logistic, and log-log demand models. Also, for this part, we showed that we can compute the solutions for multiple groups efficiently. But let's focus on the findings. First, for price fairness, we find that a little price fairness is always beneficial, but too much fairness may still force the seller to give up group 0. But for now, because the demand is always positive, we say the give up in a soft manner. But still, it will lead to a lose-lose situation. So here we are showing you some examples of different demand models. You can see that the top left is linear, and the rest 3 panels are exponential, logistic, and log-log. And as you can see, the price changes is like the price for the high valuation group is first decreasing with alpha, but then it will goes up, and very close to the unconstrained optimal price in all the 3 cases. So in that case, the low valuation group is actually given up, and the demand for this low valuation group will be almost 0 when alpha equals to 1. So correspondingly, if we look at the social welfare, for small alpha, the social welfare is increasing. However, when the price fairness is too much, then the social welfare will have a drop, leads to a lose-lose situation between the customer and the seller. So this is for price fairness. For demand fairness, we find that it always decreases social welfare under exponential and logistic demand models. For surplus fairness, it always decreases the social welfare for all demand models. And finally, for no purchase valuation fairness, a little fairness may increase the social welfare for exponential and logistic demand, but the social welfare is not monotonically increasing with alpha anymore. So to summarize, we propose a framework to investigate the price discrimination with fairness constraints. And different fairness constraints cannot coexist in general. Also, the impact of fairness depends on the type of definition as well as the level degree alpha. Analytically, under linear demand, we show that a little price fairness increases social welfare, but too much of them may lead to a lose-lose situation. Demand fairness always leads to a lose-lose situation, and surplus fairness always decreases the social welfare. And finally, no purchase valuation fairness, which is something new, will always increase the social welfare. And also we test our results numerically under other demand models, and most of our findings hold computationally. So this is what we have. The paper is online, and if you have any questions, I would be happy to answer. Thank you.